After thousands of years of trying to understand what is out there in the universe and what our place in it is, we have developed an explanation so mind-blowing that people of the past would think us to be crazy if we told it to them. Our best explanation can be simply put as follows. We live on a planet that, along with 7 others, orbit around a star which we call the Sun. This is our solar system. This star, our Sun, is part of a collection of billions of other stars which we see in the night sky, which we call the Milky Way galaxy. The Milky Way galaxy, however, is just one of billions of other galaxies. And sometimes when we look up in the sky and think we've seen a star, we are actually seeing a whole new galaxy made up of billions of stars, so far away that it just looks like a white dot to us. All these billions of galaxies put together is what we call the universe. The key to understanding the motion of objects in the universe is to understanding orbits. An orbit is when one object travels around another object and continues to do so. A good example to study while we explain the key features of an orbit would be the moon orbiting around our planet. The first feature to notice is that at least one of these objects are massive, and so there is a strong gravitational force that pulls them towards each other. The second feature is that the Earth is much more massive than the moon. This means that the gravitational force doesn't have that much effect when it pulls on the Earth, but it has a very big impact when it pulls on the moon. The third feature is that the moon is moving relative to the Earth. This feature is clearly necessary. If we drop a rock on the Earth, it doesn't orbit, it crashes straight down to the ground. And if the moon were completely still above the Earth, the gravity would simply pull it down to the Earth, causing a catastrophic collision. The speed of the moon means that it won't crash down. The situation now looks like this. We have a huge Earth that barely even notices the moon is there. The moon, however, is very aware of the Earth since the gravity is strong enough to completely change its motion. It tries to fly past the Earth, but instead of being able to, the gravity force keeps pulling it closer. At every point, the moon is being turned towards the Earth as it tries to fly past, forming a round path called an orbit. In the universe, as long as these features are present, we are able to say that one thing will orbit the other. For example, replace the word moon with satellite, and we still satisfy the 3 conditions, and so we know a satellite will orbit around the Earth. Replace the satellite with the Earth, and the Earth with the Sun, and now we will see why the Earth orbits the Sun. We will see that comets also fly around the Sun. What about the motion of the moon around the Sun? Well, it does indeed orbit the Sun, but since it's also orbiting the Earth, its motion will look something like this. We can see this is more complicated, but really it's just a combination of simple orbits, the Earth around the Sun and the moon around the Earth. These orbits, or combination of orbits, occur all over the universe. And the same principles describe why a satellite orbits around the Earth as why a star will orbit around a black hole. We can investigate this in a bit more detail. Let's assume that the moon is orbiting the Earth in a perfect circle like this. We know that the moon is about 385,000 kilometers from the Earth, and so we know that this is the radius of this orbit circle, which we call r. We also know that it takes about 28 days for the moon to fully orbit the Earth. And this is the period of the orbit, which we call t. We use circumference is equal to 2 pi r to find out that the moon must travel a total distance of around 2.4 million kilometers when it goes around the Earth. And since it takes about 28 days to complete this, we use speed is equal to distance over time to conclude that the moon must be travelling at a speed of around 85,700 kilometers a day, or about 1 kilometer per second. We use this same method for any orbit. The orbital speed v is just given by 2 pi r, where r is the distance between the two objects, divided by the time period, the time it takes for one full orbit to be completed. A final note to take is about gravity. Gravity is caused by massive objects and the strength of gravity depends on how massive the object is. This means that the gravity you feel on Earth is different to the gravity you would feel on the Moon, since the Earth is much more massive. You are used to using the gravitational constant g in energy questions. On Earth, this constant is around the value of 10, but be wary that this will not be the case on the Moon, or on Mars, or on any object that does not have the same mass as the Earth.